Can you imagine a world where fireworks could not explode, cars did not move, food did not cook, a world where the air we breathe, the water we drink, and even the earth we walk on does not exist? Welcome to the world of chemical reactions. Chemical reactions are building blocks in the universe that transform one substance to another through a series of intricacy processes. Example, from roasting of iron to baking of bread, chemical reactions are all around us that shapes our daily lives that we often take for granted. In this journey, I'll be exploring the fascinating world of chemical reaction, discovering the principle, the processes, and the products that makes our world. Come closer and buckle up. Let's ignite the reaction that will change the way we see the world. Welcome back to my YouTube channel. My name is Ayodele D. Castle, a privileged host on this channel. If you are here to subscribe to this channel, what are you waiting for? Quickly now, hit the subscribe button and the like button. Comment reaction and let's get started. All right, quickly, let's look at chemical reaction. Okay, by definition, what is chemical reaction? By definition, let's look at what chemical reaction is. A chemical reaction is a chemical change in which some new chemical substance are formed. In other words, we have what form a product. That's why we're taking another definition, say a reactant. These are substances which undergo chemical changes. Why products? These are the new substance formed from the chemical reactions. Okay, we'll be exploring the different types of chemical reaction. Number one, we have what is called chemical combination. We have what is called decomposition reaction, displacement reaction, double decomposition reaction, catalytic reaction, reversible reaction, thermal dissociation reaction, and oxidation and reduction. We'll be exploring these 8 types of reaction. Okay, so let's look at number one. Well, we said chemical reaction. This is a reaction in which 2 or more substances combine to form a single. Okay, you can say 1 plus 1 is giving us what? 2. In other words, 2 things are combined together to give us 1. Look at its elements, combine with elements to give us what? To give us a compound. Now, I have iron here, combine with the sulfur to give us iron to sulfide. In other words, that's element combining with element actually. We can also have a compound combining with a compound to give us a bigger compound. Now, I have the 2 oxide combining with sulfur 4 oxide to give us what? The 2 times will be 6. Can you see? Can you see it now? In the first reaction, first example, I gave elements combining with elements. While second reaction is talking about compound combining with compound. What you are saying in essence is that when a combination reaction occurs, minimum 2 or more substances are combining to give us only single compound. Did you get it? Let's go to number 2, decomposition reaction. This is a reaction in which a single compound, you got it, or single substance splits into 2 or more simpler substances. Note that when it is needed to bring about decomposition, the reaction is known as what? Thermal type of decomposition. Look at it now. We have CaCO3. This calcium also carbonate 5 to carbonate 4, calcium carbonate 4, decomposing to give us what? Calcium oxide and carbon 4 oxide. One compound decomposing to give us 2 substances or more, and we have lead nitrate there decomposing to give us lead oxide, NO2, and oxygen. Oxygen gas is a gas. Oxygen gas is also a gas. Okay, yeah. So let's quickly move on. Okay, let's move on. Now, number 3, you say displacement type of reaction. Displacement reaction is a reaction in which one element, or we call it radical, replace another element or radical in a compound. One element, okay, or we call it radical. Radical are a group of atoms that in their ionic states. People that cannot remember now. Okay, now replace another element or a radical in a compound. Look at it now. A now plus B, C, giving us what AC and B. In other words, A now is what? Replacing the position of what? Of B. To form AC and BC. In the same way, we have zinc now, replacing the position of what? Of copper. In other words, zinc is displacing copper to form zinc sulfate and copper solid. Did you get that? Number 4, double decomposition reaction. Double decomposition. This is a reaction in which two reactants are both decomposed to form new substance by an exchange of radical. Two reactants, A plus B, AB plus CD, will give us AD plus CD. In other words, these two reactions, we have to split. Now, look at this one. This one, silver nitrate will split to AG, CAG plus, okay, while NO will give us NO3 minus. Then sodium chloride will split to Na plus, and chlorine will split to what? Ca minus. In other words, there will be attraction. Okay, remember I will say like poles does what? Does repel, unlike poles does attract. So this positive will be attracted by this negative, which is chloride ion, while this nitrate ion will be attracted by what? By sodium ion. That's why we form this. Can you see it now? So we said the two of them decompose. Silver nitrate decompose. At the same time, sodium chloride also decompose. Then like poles and unlike poles rule take place to form the product. The same thing happens to a potassium nitrate and there will be 6 what? Acid. The same thing is this reaction. Did you get it? Now let's look at number 5. Catalytic type of reaction. This is a reaction in which substances are used to alter what? The rate of chemical reaction. We use substance to alter the rate of chemical reaction. So we have different types of catalysts. Anyway, okay, we have maybe we look at that catalyst. We have homogeneous catalyst and we have heterogeneous catalyst. Homogeneous catalyst, this is a catalyst in which the catalyst reactant and products are all in the same phase. In the same phase, the oxidation of sulfur 4 oxide give us that. Now look at it. Look at it. They are in the same phase, gaseous phase. That's an homogeneous type of reaction catalyzed by NO. Now, heterogeneous, this is a reaction in which the reactant and products and catalysts are in what? In different phase. Look at it here. I have all the reactant, the product, and the catalyst, they are in the same phase. They are all gaseous. But for heterogeneous, look at my catalyst, the ion is solid, all right? My reactant, nitrogen gas, hydrogen gas, and ammonia gas. They are not in the same phase. They are in different phase. Okay? When I'm talking about it, we're not talking about phase me and phase you. We're talking about the phase of reactants and the products, whether they are solid, they are liquid, and they are gas. That's the state we are talking about. And in this one too, hydrogen gas, platinum is what is solid. HI there is giving us also solid. Now look at this vegetable oil, production of margarine. We also have the same thing. Our vegetable oil is liquid, hydrogen is a gas, our catalyst, the nickel, is what is solid, while our product is also solid. So let's look at number 6, reversible reaction. This is a reaction in which one proceeds in both directions under suitable condition. To represent reversibility in a reaction, we use this type of arrow, showing that the reaction can proceed forward and at the same time it can also proceed backward. That's the symbol we use. Look at this reaction here. Look at this reaction. Look at this reaction. A plus B to give us this. At the same time, we can have a reaction where we have nitrogen gas. Okay, nitrogen gas plus hydrogen gas in a reversible reaction to give us ammonia. Just quickly let me manage that space. Ammonia gas. Okay, all of them are in gaseous state. But I'm just trying to depict a reversible reaction. It shows that this reaction can be a forward reaction, at the same time can be a backward reaction. Number 7, thermal dissociation. This is a reaction in which each molecule of a substance dissociates into two or simpler molecule or atom or the application of what of heat. Unlike thermal, okay, decomposition. Thermal dissociation is what is reversible. Okay, is what reversible. Do you get that? Thermal dissociation is what it is reversible. So look at a substance here that under the influence of heat can but that can dissociate into ammonia and hydrogen chloride gas. In other words, if you have gained anything from this video, why not press the subscription button and share and like the video? And I will see you in my next video. Have a great day.